Hey guys, what's up? Eddie Yahoo here with kissanalog.com. All right, so I've got some measurements to show you on interconnect cables, and I've found something that shows a difference in cables. I want to show you guys what I found. Now, I've done videos on power cables, and I've shown you why power cables just don't make a difference. But if you like a nice cable, that's only 50 bucks and it checks a lot of boxes. So I'll put the link for these below, okay? I have affiliate links that help support the channel, so appreciate using those. Now, I've got some speaker cables. This is an old Kimber cable I've had for a long time. I've got a couple speaker cables. We haven't talked about those yet. We've been talking about interconnect cables for a while now. I kind of got into it because I was testing this IEMA A07 Max, and it's Class D amplifier with the Quant Asylum QA401. I also have the Omicron Labs device. I've got a number, THD meter from Keithley. I've got all kinds of things. I've got the phase gain meter from HP, who's Agilent now. Automatic distortion meter from Kronheit. I've got all kinds of test equipment. And I have something really nice down here I've got to start using. But here's the thing is, I did a bunch of tests with interconnects, just, phase gain, bandwidth kind of measurements. Don't show anything, okay? But the test today, I did find something, and I want to show you how I did that. Now, the one thing I want to say is I am an engineer. I've been a power supply specialist. That's kind of my specialty, which, signal integrity, power integrity, been in EMI chambers, a lot. Doing a lot of EMI testing. So I know about sensitive signals and what kind of shielding works, what doesn't, and what's important and what isn't. And we're talking audio frequencies here. Now, there's a couple other channels on YouTube. There's Amir, Audio Science Review, which I really respect him and his work. And then there's another guy, Gene Della Sala. Probably butchered his name, sorry about that. And he's from Audioholics. Respect his work as well. And then I do a lot of research. So I saw some other videos, found somebody else doing tests. And they were doing tests on speaker cables, interconnects, and the like. And they said, well, they couldn't show any differences. And they even admit that in the audio spectrum, there's no difference. They make a lot of assumptions, a lot of miscues in there, I think. They come to some conclusions, which I don't know how they get there. They show a wide bandwidth, which I've done as well. And I've shown the cables. I've shown a bunch of different cables here for interconnects, and they perform at very high frequencies. Out around 300 kilohertz is where we start getting high frequency. And you start seeing differences out there. And they did some stuff they call, I don't even know if I want to talk about it. But anyway, they talk about spectral decay and things like that, which is absurd when you're talking audio stuff, okay? The wavelengths and all that, it just does not apply. So, so that's just craziness. But I think it was because, first I thought it might be an engineer, but I don't think he is from the way he talked and, his conclusions and some of the testing methods they're using. And he kind of admits that he got testing methods from people on the web. And then also, I've never been paid to do a video, and I don't have any, I have equipment that people have sent me for free to review, and that's the gist of it. So I've never been sponsored. And when some of these people say they're not sponsored, but yeah, maybe that video wasn't paid for, but the cables that they got, really expensive cables, and the people that gave them the cables are in the test with them or doing the audio listening with them, or their website shows all these high-end cables that they're selling. That it kind of smells a little bit, right? So anyway, and it seems like a really nice guy, and they might be very mean, trying to do the best they can. But then again, there's no double-blind tests or even blind tests. And so the conclusions, you know, drawing lines with things that are placebo effects and saying that's a conclusion. It's not science. So when you mix science with placebo effect and then you still call it science, that's not right. So anyway, I'm going to show you some tests, okay? Because this has been a long debate, and I'm going to show you some tests. And then after the tests, we're going to talk about, you know, can you hear it? But anyway, let me show you what I found first, okay? Let's just jump into this thing. All right, guys, so here's the deal. I've got a power supply here. It's an AC power supply. It's the IT7321 from iTech. Really nice machine. It puts out a dimmer voltage. I'm going to show you that. And I'm capturing that here on the mixed sig right here, but I'm going to capture that and show you a bigger picture here. But what I want to show you is the power from that's come through a zip cord, you know, power cord here, and then it breaks out into my red and black test leads, okay? And then they come over here to try to make sure it's not too hot. This 91 watt resistor, okay? It's 18 ohms. So I'm going to put out close to 50 watts. I think that's enough to try to induce some noise into my interconnect. And I'm going to start off with this homemade one right here, okay? And here it is, 18 gauge speaker wire, just zip cord, right? So now I got to say something. It's wires side by side, it's not twisted. But you know what? Side by side, close like that, it's the next thing best to twist it. So the field rotating down the wire, one wire going this way and then coming back, rotating the opposite way, coming back, those fields cancel. So even though they're not twisted and overlapping every inch or whatever, it still provides a pretty decent self-shielding. And that's what twisting does. So, all right, so what we do is we're coming out of the Quant Asylum and we're going into the IEMA A07, all right? And I'm putting out about, well, it's about 1.6 watts is what it's equivalent to. And I put a small signal out to see if we can, you know, the signal noise ratio. If I put out a big signal and the noise is small, it just looks like separated by a wide margin. But if I put a small signal out and put in some noise, and if the noise, you know, brings them a little closer. So I'm trying to give a worst case scenario. And also, if you're listening to lower levels, say 1 watt output, I think this was 1.6 watts output. I was trying to hit 1 watt, but I think I hit 1.6. Anyway, when you're putting out a smaller signal like that, then if there is noise in that, maybe you'll hear it, right? Because there is the, oh shoot, what's the term called? You know, when you have like say 60 hertz noise, but you have a drum beat or something in that you know frequency band, it kind of drowns out the noise. And yeah, I can't think what that term is right now, guys. Let me know in the comments. So same thing with high frequency. You got a high frequency pitch, but you got some high frequency music. It kind of drowns out the noise. So it's a signal noise thing. Plus, the ear can only pick up so much, I think is what it is. But anyway, I'm putting out a small signal. That's why. So, all right. So here we go. Now, first what I'm going to do, so there's red and black wire right here. It's coming from the end of this power cord right here over to the resistor. And I did it that way so that way I could twist this interconnect in with this. I'm going to take the red wire and twist it in with that, okay? And then we're going to see if we can pick up any noise that's going to this dimmer load over here. Worst case scenario, right? Now, here's the other thing, is the red and black wire, they're not side by side like they were in the power cord. So power cords side by side are going to work better. And I'm going to kind of demonstrate that too, okay? But first what I want to show you is I just want to show you the signal on the scope, what it looks like coming out of the Quant Asylum. Now, you may have noticed back here, every so often it flashes up, it changes, and then the signal settle back down. And I think it's taking a bunch of measurements, and every so often it just has to reset and start over. So it's the way it works. So in between the times it's resetting, we just wait for it to come nice and still. Sometimes it's up, there it goes, pops up, and then it drops down. Sometimes it stays down for long periods. Sometimes it pops up and changes more often. I'm not sure why that is. All right, so first thing I'm going to show you is the wire's just crossing over this power wire, and I don't have it turned on. So I'm going to show you what that signal looks like, kind of, you know, our baseline where we're starting off. And I'll just kind of show the worst case scenario where I have this interconnect made out of speaker wire, kind of just laying kind of close, maybe not even touching, but it's just laying across kind of 90-degree angle, which is the best way to cross the wire so you don't pick up something. But anyway, so let's go ahead and let me show you this screen. Okay, we'll see where we start off. You know, clean as possible signal for this, and then we're going to just twist it up, okay? Oh, and incidentally, I did this test once before, and I thought with my homemade wire I was going to show some coupling, which I'm going to show you today, but I failed last time. You know what I did? I twisted this red and black wire together, going over to the resistor, and then I twisted the interconnect in with that twisted set of wires, which is probably more realistic, like what you're going to see behind your equipment. You're going to see a power cord like this, where maybe it's not twisted, but they're side by side. And if your interconnects lay against them, somehow get twisted up in them, which that's called cable management. You keep your cables separate, or if they have to cross more like that, you know, keep them away from each other. Don't twist them up. So this is a worst case scenario, but we want to see what shielding does. So that's why we're doing this test. Okay. So anyway, having them split apart like this, even right here, the fields are going to be kind of going bigger. Instead of canceling and having smaller fields, they're going to be doing this thing where they, you know, so, all right, so let's see what we pick up. Okay, guys, just to show you the power, it's coming from my iTech power supply up here, comes down, well, down to the zip cord, and then comes over to these red and black wires, okay? Red and black wires come over here to the resistor, all right? So that's what they look like, and here's my fancy-dancy homemade interconnect, and I'll just kind of do it like this, and then I'll push it against it and turn on the power supply. So we see that dimming waveform. See how nasty that is? Sharp edge, well, it bottoms out. It's like a Class B amplifier, but worse. So yeah, pretty bad. Sharp edge here, sharp edge, and it's off, and then it comes up, ramps up really fast to try to get that sinusoidal, and then it kind of goes sinusoidal up here and then shuts off. So really bad waveform. Okay, guys, so here's the signal, the 1 kilohertz. It's about 13 dB. Yeah, so this right now is about 2.5 watts. I'm going to drop this back down for the rest of measurements closer to that 11.1, so it'd be closer to 1.6. Right now we're about 2.5 watts. So that's the signal. And here's our harmonics. Second harmonic way down here, fourth, you know, you can see that even, well, maybe there's a 6, kind of comes and goes, but the odd harmonics are usually more prevalent. So we have the third down here around -70, so that's pretty low. And then we have, you know, the fifth down below -80. So these are all really low. And now look over here, 60 hertz. In the US, I got 60 hertz power, so I am picking up a little 60 hertz noise, but it's all the way down here at -90. So very small, guys. And then here's 120, second harmonic from this guy, right? And so then they kind of fade away, okay? So we'll probably see these guys pick up, maybe all this stuff pick up once we twist it. Right now, we're at 0.00694, so 0.007, there you go. So that's 2 zeros, pretty low. 0.008, this is with noise, so total harmonic distortion, that's all those harmonics. That's this one and all these guys over here, evens and odds. And then all this other noise and the 60 hertz stuff is considered noise, and that's in this measurement. So it's 0.008. So that's still super low, guys. And then we have 87.95 decibels of signal. This is signal and noise ratio, okay? That's the signal to all this noise. So 87 dB. That's huge, all right? So now remember, 0 is 1 volt, okay? So
this would be 100 millivolts. It's every time you go 20 dB down, it's 10 times less. So 100 millivolts, 10 millivolts. Minus 60 is 1 millivolt, and minus 80 is 100 microvolts. Okay, that's microvolts down here. So, and minus 100 is 10 microvolts. So let's say this peak right here is between 10 and 100 microvolts. Okay, so these guys are really small. This guy's below 1 millivolt. He's between 1 millivolt and 100 microvolts. Okay, so very small stuff. All right, now I'm going to go ahead and with wire just laying right across it, maybe I'll push it down against them. Do you see them come up at all? Okay, I'm going to go ahead and turn on the dimmer power supply. And do we see anything? It looks like it hasn't changed. So I'm going to stop that. Okay, and I'll save that picture.
Okay, guys, so having this wire laying across this noisy wire, before I didn't have the power on, then I turned the power on, and I pushed this wire next to him, so it was laying on top of him. But even though it was doing that, just crossing over like that, no pickup, okay? Now, if I held the red and black one real close together and did it, it'd even be better, okay? Because then they'd be canceling the field. But spread apart like they are, you know, the spread apart ½ inch to an inch, and me put, you know, my finger down, pushing the wires against, didn't do anything. So we're going to go ahead and twist the red wire in with this, okay? So make sure that's off. It is. I'm going to take this off, and I'm going to drag this over here because I want to twist have it twisted along this is the full length of this red wire, this test lead, nice and tightly coupled. Okay, so it's nicely tightly coupled. Okay, so I'm going to go ahead and test that now. Let's see what that looks like. All right, guys, just wanted to show you a close-up of that. Here's the power leads right here coming over. The black one's right here. I think I'm going to lift the black one up a ways so it's not even close to being coupled. I think I'm going to drape it across here. So I think I'll do that, okay? But on one hand right now, I can't. It's hard to do it. So anyway, here's a twisted wire, the red wire, in with my beautifully crafted interconnect. And the rest of it is, I'll just coiled up here, lay it, try to get as much coupling as possible. There's a resistor that's probably starting to get hot. Okay, so it's turned off right now, but that 91 watt resistor gets pretty hot with the about 48 watts on it. So, all right, so then from here, we go, okay, so from here, we come up into the amplifier, okay? So we're coming out of the Quant Asylum through the twist. We're going to see what noise we pick up that goes into the input of the IEMA, and then we'll measure the output and see what we get. So the output's coming in here, it's differential. So, and this is an 8 ohm load that we're putting on that channel. So, all right, get my computer cords away as much as possible. They're also, you know, shielded and all that kind of stuff. So they're not going to induce anything. I've put them next to it, moved it away and all that kind of stuff just to see if it shows up and nothing. But just to, you know, just to make everybody feel better about it, maybe I'll put this underneath there to hold place. Okay, so let's go.
All right, guys, so this is the screen where we left off. Okay, now that I'm connected, twisted up, let's see how much coupling we get just by being twisted. All right, well, actually, I'm surprised the 60 hertz stuff went completely away. You know, that 60 hertz stuff seems to come and go a little bit, I think. I'm not sure. But, wow, okay. That's totally gone. And then we still have this stuff over here. So the THG up here, THG plus N, still looks about the same, right? Okay, make sure all my connections are good. I'm going to turn on the power supply. Let's see what we get. Okay, we got the dimmer power supply up, and see what the dimmer did is it just induced all this noise. But look, it's down. This is minus 90, so it's, wait for it to readjust. Minus 95 is right here. So it's just, you know, it's right between 95 and 100 dB. So this is microvolts, okay? I mean, this is really small stuff. Meanwhile, the harmonics here never change. Up here, look at this. Wait for it. look at this, 0.0086 now. So maybe went up slightly, and 0.0069 or 0.007. So there we go, guys. That's how we're starting this test, and that's how we're going to continue doing this test with different cables. We're going to try different cables, see what happens.
All right, guys, like, subscribe, do all that stuff. Really appreciate it. Like the video, subscribe if you haven't done so. Let's jump back in. All right, so just before I jump in this video, let me just point out, I got my little 18 gauge, zip cord here, okay? Now, the interesting thing is wire, when it's, even if it's not twisted, when it's just zip cord, it's funny how zip cord or just this wire just being coupled next to each other actually helps cancel a lot of the field, even though it's not twisted. It's the next best thing to twisted. So it surprisingly, just a plain old zip cord does a good job of canceling the field. So in this test, even though we're separating these things to try to conduct something into the interconnect, it's very, worst case kind of thing. You wouldn't do that, right? All your power cords behind your equipment's going to be zip cord, or if you spend a little more money on something else, but you don't need to spend a lot of money on power cords. You really don't, okay? Just zip cord is going to be good. It's going to self-cancel. In this case, I had to break it apart so I could twist it to do this test. All right, so we're going to do my homemade little 18 gauge cable, okay? We're going to do the Kimber, the silver, it's called the Silver Streak, okay? This one's the one that's probably $400 or $500, something like that. Very nice. I mean, it's actually got silver wire in it, and it's brand new. I've taken very good care of it. Oh yeah, the burn-in thing. Bullshit. Anyway, yeah, it's very nice cable, okay? Silver wire and stuff. And then we're also going to use this monster, okay? It's this red jacketed cable, and I've had this for a long time. This monster is called the Special Multi-Phased Alignment Interconnect. So, very fancy name for, basically, I think it's some type of coax, okay? Not sure. But then I also have this monster cable, okay? Kind of a big beefy one, and very nice ends on it. This is a very nice cable. It's an interlink high resolution lit interconnect cable. That's what they call it. So again, kind of a coax cable, okay? And then like the Kimber, we have this IXOS, or I don't know how to pronounce that, but IXOS cable, okay? And that is the Gamma, okay? I've got the Gamma. Now, I bought this for $45 on a closeout. Can't remember what company it was. Ultimate Electronics, I think, was going out of business, and they were just dumping things. So I bought some of these cables. I might have got that Kimber on the same sale, but $45 for this. So that was a good deal, I guess. But anyway, it's a Kimber cable. I mean, it's built like Kimber. It's a braided cable. So, and then I've got my coax cable, okay? I got a little short one, and I did a bunch of testing with, I have a whole bunch of coaxes here. I just did that because it's easy to twist up. And then I have this coax. It's actually in the test right now, okay? And this coax is this kind of gold colored one. And this is the new one I bought. Put the links down below. This is the RG400. It's just a heavier, I think it's a heavier conductor coax than the typical coax. Other than that, yeah, I think it's just meant for RF or more, when you're putting more power through it. So yeah, so somebody on the comments suggests I use that, and I got it, and it is a nice beefy cable, nice connectors. So that's the other cable. I think that's ones we're going to test. So let's jump in this testing. Let's do it. All right, so this can be interesting. I've got the BNC cable in here, okay? So it's wrapped up with red wire, let me show you that. All right, so what I've got is the power cable. The red one has been wrapped around this BNC, okay, all the way over here to where it breaks off and it goes into the back of the amp. So it's twisted, you know, very well, very tightly. And here's that resistor, okay? So the black wire is just sitting right here. As a matter of fact, I'll just loop that up there like that, okay? So the black wire is just sitting up here like this, and we got this. So now let's go ahead and see what we got.
All right, guys, so let's go ahead and look at this. Wow. Okay, the 1 kilohertz, the harmonics, they probably are the same amplitude as they were before. We'd have to go back and compare. This is minus 100 decibels right here. So we're 80, 90 right here. We're below 90. So this is crazy low. If we go up here, we see 0.0049 and 0.0067. So, man, things got really so much better. All the noise, see how this ground noise, the noise floor here just dropped. And man, it's crazy good. And signal noise, 87.4. So, wow, that cable did make a huge difference. Okay. Man, I'm surprised. It's amazing. Okay, so let's go ahead. Okay, now I'm going to turn on the power supply right now. Did we see anything? 87.5. Okay, now we're recalibrating. 87.6 maybe. 55.0066 here. 00489. So how does that look? Okay, I'm going to turn it off and let's see how it changes. Okay, I just turned it off. Wow. Yeah, that cable does an amazing job.
All right, guys, I'm amazed. Wow, the shielding actually does help, which I always thought it would, but the last video when I was doing this, I didn't really see that big a noise change with just the homemade 18 gauge wire, but it's because I twisted both the positive and, you know, the AC wires. There's not a positive in return, but you know what I'm saying. I twisted both cables that are, and that helps them cancel each other. Even the noise was canceling really well, which, yeah, that still is amazing that just a zip cord or twisted wire can cancel that much noise. But if you were to separate your power wires, and if one was to get wrapped around your cable, it does help to have a coax. It helps a lot. And you know what? I'm really curious now. Let's take my expensive Kimber cable, okay? My silver wire Kimber cable. Let's take this expensive dude and see if it does as well as the coax. All right, guys, I got my expensive Kimber cable hooked up, and this cable is called the Silver Streak Kimber cable, and yeah, it's pretty expensive. Yep, there's the cable right there. Okay, now here, let me show you what I've done. Is I've got the red wire from the power, from the dimmer, right, coming, twisting along this wire, and it's the same length of twist. From this red wire is kind of short, so I get same number of twists, I think. And here's the rest of the Kimber. It's kind of long, so it's draping over here. But yeah, let's go ahead and see what that looks like. And the black, again, is draped across the top, same as before. You know, coming from the power supply here, yeah, it's just draped across the top. Okay, so we're not twisting that in like I did the first time, last video. Okay, guys, so here's the signal. Now, the signal is looking pretty amazing. Look, 60 hertz and 120, all the power stuff's almost gone. Now, just be sure that something in the house didn't stop running or whatever. I'll put one of the other cables back on just to make sure, because I noticed these things were up a little bit higher than they dropped down. So, and I've moved the cable around to see if, well, see if I move it around a little bit. Actually, if I just hold it, and then here, let me let go of it. Yeah, it's kind of weird. It's like I'm an antenna for 60 hertz noise, I guess. But anyway, yeah, that's weird. Now it's just recalibrating. Okay, it's back. All right, so anyway, that's that. Those noise spikes come up a little bit, and I'm not sure if it's the cable, because I noticed it's been dropping, but let's say, I think, okay, we're going to give credit to the cable for now until I can prove otherwise, but I want to investigate that a little bit more. Okay, here's our 1 kilohertz up here, our harmonics down here just like they did before. Now they should be all the same amplitude as far as these harmonics. We are seeing even harmonics in here. Maybe it's just because the noise floor is so clean, right? It's way down here about 110 dB almost. So 88.7 for signal to noise ratio. We got 0067 for THD plus noise, 0055 for THD percentage. So I'll have to compare these during my editing to see how that looks, because I didn't write them down. So we're going to just have to go off memory here, or off the video. Okay, so guys, so now I'm going to go ahead and turn on the power supply. Hopefully, okay, there's the power. And look, it is coupling more. You saw these spikes kind of, but still, guys, this is minus 100 dB. I mean, okay, let me turn it off. And there we go. So here, I'll turn it back on again so we can capture that. And it comes back up. All right, so I'm going to go ahead and stop that. All right, guys, I put the coax back on. I don't know if I called it a BNC cable before. Anyway, coax cable. It has BNC connectors on both ends. But anyway, I put it back on, and you can see that the 60 hertz and 120 harmonics did come up a little bit again. So it is there. And I noticed that it's really sensitive. Like if I just touch the cable, look what it does. It just drops really far down. So it's kind of interesting. Yeah. So you can kind of see how it kind of goes up and down. Just, yeah, not sure. So it looks like the silver cable was doing a better job on the low frequency shielding than the BNC. And it could be because it doesn't have a shield to bring the noise from here to this box. You know, it just has, I mean, anyway, it's designed different, right? The return is the shield, and the Kimber, the shielding isn't as good at high frequency. We saw more of that pop up than BNC. But at low frequencies, more magnetic coupling, it's better not to shield both ends. And since the Kimber is not really shielded, the coax cable, by design, the return is kind of shielded. So one time the shield kind of works as a return. But anyways, yeah. So it does seem to work. The Kimber works better at low frequencies. Now I want to try another cable. All right, guys, let's try a monster cable. I'm going to show you the monster cable right now. All right, so here it is. It's connected. And I've got this twisted just as tightly as I can all the way up here. And then we have the excess just coiled up in a couple coils. So right there. And yeah. And then the black return wire, again, just going up over the amp down the other side. So yeah, the resistor, the amp's pretty warm after doing this testing for so long. But anyway, let's give it a go. Okay, guys, we have the monster cable hooked up. Okay. And as you can see, I mean, look at this. The harmonics and the 1K frequency, all that should look the same. Noise floor looks a little bit higher, looks closer to the Kimber, maybe, I can't remember. But look at this. The AC power noise kind of popped up a little bit. Still, minus 80 dB. Still, it's way down there, okay? So just, you know, 0 is 1 volt. This is 100 millivolts, 10 millivolts, 1 millivolt, 1 microvolt, okay? So we're way down here still. But anyway, let's go ahead and turn on the power supply, see what we get coupled. Okay, we're running. Okay, there we're running. I had it turned off, and look at this. I don't see really any difference. Now look close. We'll wait until it calibrates. Okay, I'm going to turn it back off again. And it takes a couple beats. Yeah, it did. Shoot. Look at this. Oh man, I wish I could just make it go steady. But anyway, all right, guys. So anyway, look at this. 100 dB right here, right? So we're down here around That's annoying. Okay, we're down here, the line, this is what? 110 right here says 90 dB. So you see the noise right around this first line? Okay, pay attention to that. Turn on the power supply again. Okay, the dimmer power supply is on. I saw some stuff pop up right through here. You see some stuff pop up, right? Now up here, 85.00814.005. 568. Okay, I'll turn it off. And it changes ever so slightly just because all this stuff is so low. But anyway, that's pretty interesting, right? All right, guys, I have this white IXOS, IXOS, I don't know. Anyway, here we go. Show you that connection. So here we go. It's wrapped into the red right away, just like I've been doing, all the way up to the length of the red. And then I just coiled up the rest of it. So there we go. Now, obviously, you wouldn't want to coil your wires. You'd only want the length of wire you need, right? But, so it's kind of worst case scenario, I guess. And then again, the black return wire up over the top, down over here, okay? So the dimmer power supply coming in here, getting twisted, all that kind of stuff. Okay, let's go see what it looks like. All right, guys, I think I'm seeing a trend here. Take a look. Here we are. Now, again, the 60 hertz, 120 hertz stuff, the power supply stuff, man, it's almost non-existent, just like the expensive Kimber. All right, there's our 1 kilohertz signal, fundamental frequency. Here's our harmonics, second harmonics, the even harmonics down here, the odd harmonics a bit higher. So you can see them better now because the noise floor is below 100 decibels. I mean, look how low the noise floor is down here. Up here, we got 86.8 signal noise ratio, 0.00745, 0.0056 for THD. So with noise, we got a little bit more. I mean, God, we're way down in here. I mean, it's crazy. Double digit zeros, come on. All right, so now keep an eye on. Here we go. Turn on the power supply. And look at that. Just like the expensive Kimber cable, it kind of pops up. You see the noise spectrum through here. But still, guys, this is like 95 dB. It's still, look at the signal noise, still almost 85. 0.008. I mean, still we have double digit zeros here. So still crazy low noise. Yes, it makes a difference, but can you hear it? All right, guys. So you know what? I think we see a trend, right? That nice Kimber woven, you know, the way the Kimber does a braid, and then this IXOS brand does a braid as well. Not sure how the patent worked out there, but anyway, it looks like the trend is that those kind of cables do very well at low frequencies. They filter out that low frequency 60, 120 hertz harmonics from the 60 cycle stuff that gets picked up somehow, right? But the higher frequencies across the band do pop up a little bit with this coupling. But guys, still, is it significant? I mean, the noise is so low. Hey, we're seeing a difference. That's what's important. And of course, we can measure it. Whether we can hear it or not, we can measure it. So yeah, you know what I want to do is I want to go back to that other cable I bought, that coax I thought was going to be the miracle coax. Where is it? You know what? I got another monster cable, right? Got another kind of expensive monster cable. So let's do that one. All right, guys. I got the big gold monster cable. It's kind of heavy. It's a coax style. So, all right, here we go. So right here, you can see it's a kind of thick cable. Got the red wire wrapped all the way up from end to end. And then the rest of it's just kind of rolled up. It's a big, heavy cable, so it doesn't like to, lay flat or coil easily. But yeah, anyway, there we go. And then the return wire again across the amp. Okay. And back to the other side of the zip line. Now, hopefully this camera's picking it up, but yeah, there's the AC waveform. I'm just pushing this on to turn on like 47 watts. Okay. About 30 volts almost. 1.59 amps, so, and 2.3 amps peak. Okay, so the gold monster, Look at this. The 60 hertz, the AC power supply stuff kind of, kind of sticking up there again. It seems like with coaxes, we get more of that than we do the braided ones. The braided ones did a good job killing that, but still, it's below minus 80 dB. Look at the numbers up here. THG 0.006 with noise 00814 and signal noise 85.6 almost. So, and you can see the fundamental and its harmonics and even harmonics. Okay, so and the noise floor is just right here, 90 dB, kind of the high frequencies and all the way across. So, all right, so here we go. I'm going to turn on the power supply. There we go. And these coaxes do a great job. You might see a little bit pop up, but man, they do a good job. 85.48, 0083, 006. So I'll turn it off. All right, guys, let's try this other coax cable that I bought, this big one. Okay, there it is. They're coming out of here, wrapped again, same kind of way. And then it's kind of stiff, so it circles back there, it comes back around. Meanwhile, the return goes up and over the amp, just like before. Let's make sure it stays up there. Okay, let's go look at it. Okay, guys, this is what is this? RG50, or I forget which one this one is. This is the bigger coax cable. Okay, I'll put the name right here. I always forget because it's rarely used, and I bought one just for this cable challenge, or showed it once before in some other videos. So anyway, here we go. On the screen, you can see again the 60 hertz type stuff is showing its head again. It's ugly head, right? But again, it's below minus 80 dB. Okay, so that's kind of what we've been seeing with coaxes versus the braided ones. So, and then we have our the high frequency stuff over here. And look at this. The noise floor is way down here. It's almost, man, it's almost 110 dB. It's way down here. Okay, let's go ahead. I'm turning on the dimmer power supply, and look at that. So very little change, right? The dimmer, that's what the beauty of these coaxes is. Across the frequency band, they do a great job. At low frequencies, for some reason, I think they don't do they don't show the magnetic thing. I think they transfer the low frequencies across the cable too well. So, yeah. Anyway, that looks good. Oh, hey, by the way, subscribe if you haven't done so. Like the video if you haven't. That really helps the channel. Thanks, guys. Really appreciate that. And just a quick thought about why maybe the braided cables performed better at low frequency, and the coax type cables, some of them have the braided shield around the outside, but you know what I mean. When I say braided, I mean like the Kimber cable or like this one. The actual ones with shielding 360 degrees from connector to connector, that's what we call it, 360 connector to connector. If you have it pigtailed, then you're kind of opening up the window, rain's going to come in, it's all wet, so it doesn't matter that you shielded the rest of it, right? You got to close those windows, meaning you got to get the shields right to the connectors. But when you do that, it's better for high frequency, having a really low impedance on both ends. Low impedance often is better to get magnetic shielding by only grounding one end. But with these wires that we have, it's kind of interesting because coaxes, there's just two conductors, so the outer shield is one, and so you either have to have a conductor or shield. And in the case of coaxes, they kind of do both. They're one of the few cables that actually work that way. And then the other ones, they're not shielded just one end, they're braided, but maybe because they're braided and they're not really shielded that way, the impedance isn't as low on the ground side. They're equal impedance on both conductors. Maybe that's why they do better job at low frequency. Yeah, it's hard to tell. The other thing I want to throw out there is I've seen the AC noise. I'm just kind of wondering, is is it when my air conditioner kicks on that it goes up a little higher? I'm not sure, because sometimes it's slower, so I'm not absolutely sure. But it did seem like I saw a difference within just minutes of connecting one cable to another. So I think that was real, what we were seeing. But there is that outside chance that the AC was kicking on during certain times, bringing it up, and then it dropped down. But I did, and I also did do a coax and then a braided one. I kind of alternated. So I think it was real. I think that measurement was real. Sometimes when you're doing these really, really, small measurements with microvolts, the smallest things can affect it. But can you hear it? All right, let's get on with the video. Okay, guys, so what do you think? This cable right here, this coax, still pretty nice, really inexpensive. I think it's 10 bucks. I'll put the link down below. RG400, I believe is what it is. It's just a larger gauge wire, I think, for carrying a little bit more RF energy. I think it's what it was meant for. So, yeah, as an interconnect, I think it's pretty good. What do you guys think? We were able to measure difference, okay? You can't hear anything that you can't measure. Well, and you should be able to measure it. So you just got to find out how. So I think right here we showed some coupling. We showed benefits of shielding. The braided shields seemed like they did a better job at the low frequency. And the, the woven shields like the Kimber cable, the braided, they seem like they did better at low frequencies, right? Not very good at the high frequencies. I don't know if they're much better than my homemade, right? So yeah, so these kind, but can you hear it? I don't know. That's pretty low, right? At least we can measure it now. But yeah, the coax cables, like even the fancy monster cables, and so even these fancy monster cables, or my fancy, coax cable here. But yeah, I do like, now, I was going to say, I do like the Kimber cables because they have those locks. So they twist down, they lock in the RCs. You guys may have seen those on some other lower cost ones. I have some interconnects, and they're supposed to be the best in the world. A lot of people claiming that, I guess. But let's test them. So I'm going to do another video with this other interconnect cable. And yeah, we're going to see how good it is. See if it's as good as, or where it falls in with these other ones. But guys, remember, minus 100 dB is way down there. It's like 10 microvolts, right? So it's very small, and yeah, it's very teeny. So remember, every time you go 20 dBs down, it's 10 times less the voltage. So, and 0 is 1 volt. Okay, that's where you start with. So yeah, so we were about 3.6 volts, or it was up there, 3 point something volts to get 1.6 watts. Yeah, it's like 3.6 volts, I guess. So, and then I had 2.5 watts on those first couple measurements. So yeah, very small signals, and trying to couple in some really noisy power and splitting the power wires away from each other. So just using one of them to couple onto the cable, which is the worst case scenario. I guess the worst case scenario would be if I did two wires, if I just split the wires from the interconnect and twisted this against just one of those. That'd be the worst case. But come on, that's just getting absurd. I think we're already entering absurdity with this kind of test, right? This is nuts. Who's going to have dimmer power with individual wires and one of them wrapped around your interconnect? Come on. So anyway, what do you guys think? Let me know in the comments down below what you guys think. I hope this testing, I was really trying to find where there's a difference between cables. And I think on interconnects, when I showed the earlier videos showing they're totally flat as far as the bandwidth, the impedance, and everything across the frequency band, and way out there actually in the hundreds of kilohertz, they're totally fine, totally flat. I compared all these different cables. I'll put the link down below for that video. I've done several videos. I'll put the links down for those. I really wanted to just make sure my test setup was good, that I didn't have coupling and things like that. So that's kind of how I went down this rabbit hole. But then I thought, well, I wanted to do interconnects, so perfect time to do it. So there you go. Thanks for watching, guys. 2 big thumbs up to my patrons as always. 2 big thumbs up to Danny for being a team member. I really appreciate that, you guys. And 2 big thumbs up to my patrons as well. So thanks all you guys. And for the people that hit the super like button, if you like this, it did take a while to do this video. And guys, I don't have a horse in the race. I'm just trying to show technology, right? Some people say they don't have a horse in the race, but then they sell cables. Now, I'm definitely going to put affiliate links for any cables you guys want to buy, but hey, support the channel, right? So yeah, these affiliate links, some of them give me, I get some benefit. Some I don't, but I like to put them down whether I do or not to help you guys. So yeah, see. No, hopefully I try to find ones that help me as well, but anyway, sometimes they do, sometimes they don't. Long video, sorry about that. Hope it was worthwhile. I really tried to make it something that you could actually see some difference in shielding, because I was really curious myself. There you go, guys. Thanks for watching, and we'll see you next time.